Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this video, we're going to talk about data capture. This is one of the most amazing features that's available to you if you're a proud user of the TI Nspire CX2. So let's get started. Every time I talk to students about their math IEs, there are always one or two students who want to do some kind of curve fitting around fancy shapes of bridges, or curvature around roads or buildings, some interesting architecture. They try and see what kind of algebraic function best fits that curve, some kind of curve fitting exercise. To each one his own, I would say, but the more important thing, I guess, is not just the curve fitting, but to understand why we are doing that in the first place. So yes, that's a great exercise, but from the perspective of a math IA, I think you can do a lot more than just finding the equation of the curve that seems to fit along a certain path that you're trying to find out. Okay, so that's just a little advice I wanted to give you before we go on to how we can use the TI Nspire to find equations of curves along fancy shapes. So here's my calculator. This is the CAS, and why not? Why not use the CAS for such wonderful exercises? So what we're going to do is that I'm just going to go and first insert a graph page, all right? And I'm just going to get rid of this graph entry line. And what we're going to do is that there is a certain option here, which is insert. I hope you can see that on the screen. Yeah, insert. Now, on the handheld, you will have this option to insert, but you'll not have the option to insert an image. So if you want to insert an image, then you'll need to use the software, okay? That's the first thing I want to let you know. So when I say insert image, it'll give me from a certain library that's already present. When you install the software, it has this certain folder with all standard images. You can use one of the standard images, but you can also use, let me show you one of the standard images. Okay, so this is one of the standard image here of a bridge. You can just insert the bridge there, and I'm just going to insert something else because I'm going to show you this, make this demonstration with another image. So I'm just going to hit escape and get that equation line out of the way. And I'm going to go and do the same thing, image. I'm going to insert an image, and I'm going to insert an image from my hometown. And there you go. You can see this wonderful whirly sea link, as they call it. It's beautiful in the nights with all the lighting and all that. And I think there were some more interesting pictures during the lockdown. This is from this thing. Some source is nolory.com. So yeah, copyrighted image. But anyway, we are here to see how we can draw a curve that best fits something like this. All right, it's a very interesting curve here, but let's see how we can use this idea of data capture to actually plot some points along that image. Okay, but before that, before we go there, you can even, I just wanted to show that you can even move the axis around. So you can even say, okay, I want to find the curve, this curve. I'm not interested in the other curve, or maybe you wanted to do multiple of curves. But all I'm saying is that once you insert the image, you can actually move the axis wherever you want. And, let's say I wanted it somewhere there. Okay, I'm just going to put it there. Should I put it there? All right, I'm going to put it there. And can I change the color of the axis? One sec, let me just try and do that because it gets hidden. Control, and I'm not able to change the color of the axis. Is it true? Let me try and see this. Yeah, I'm not able to change the color of the axis. That's interesting. No. All right, so make sure that your image is not too dark, otherwise it'll get hidden in the black and white. So maybe what I'll do is that I'll just move this axis somewhere here so it becomes a little bit more clear, right? Otherwise it is going to get lost in the black out there. Yeah, this image is not looking good right now. I mean, I wanted to just show off my city, but this is going this way. So anyway, let me take that simpler image because it's a bit more brighter. Can you see that? And yeah, so choice of image, if you're doing an IA and if you're using something like this, make sure that the axis you can change the color of the axis. In this case, it can't be done. I'm going to change the image. That's a good approach. If it can't be done, don't force yourself, all right? So again, this set of axes, you can move it around, okay? Let's just make sure that it's active. Okay, here we go. And you can move the axis to some point where you want, you can say, okay, that's going to be my origin or something like that. Cool. And you can set the axis there, or wherever you want it to be, all right? So I'm going to just set it there. And now what we're going to do is basically we're going to drop some points along that curve. Whichever architecture you're trying to do, you're going to put some points there, and you're going to try and capture those points. You're going to try and capture those points manually. There's also one way to do it automatically, but as intricate as the curves, as the shape goes on, you'll have to do it manually. So what we're going to do is that I'm going to go first and just insert a point there, okay, just to coincide with that. So I'm going to go menu, geometry, points and lines. I'm just going to take any point there. It doesn't matter right now. And I'm just going to fix a point there. And once I have my point there, let me try and see if I can change the color of the point. The label has come there as point A. This should be fine. Color of the point can be changed. And let's make it something that stands out, shall we? All right, stands out. And maybe let's just change some attributes of that point also. Maybe increase its size. Can we do that? Empty circle. No, we don't want an empty circle. What's this? No, we don't want the animation. I wanted it to be a little larger. So thin, large. There you go. There's that large option. I was looking for that option. Okay, so you got a larger point there. You all can see it's a red point there. And I want to first find out the coordinates of this point. Okay, so I'm going to go on menu, actions, and coordinates and equations. I just click on the point, hover on the point. I get that coordinates of the point A to be 0, 2. Okay, that position of that point is marked as 0, 2. What we're going to do next is that we're going to go and insert lists and spreadsheet page. This is the fun bit, okay? So we have something going on the graphs page where we inserted an image and put a point there right now. And we're going to try and see how we can capture the point here. So I'm just going to label the first column as list 1. I'm going to call the second column as list 2. So what we're going to do is that we're going to fill up these 2 columns with X values of each a position of this point A, wherever we are going to move the point along this curved path, all right? The X coordinate right now is 0.126. So 0.126 is going to come here, and the Y corresponding Y coordinate of that particular position of that point A, right now the Y coordinate is 1.95. So 1.95 is going to come here. And so when we move that point A to a different position, the X coordinate and the Y coordinate corresponding coordinates are going to be registered here, captured here, and that's how we're going to be using data capture. But before we do that, what we have to do is that we need to convert these coordinates, the current coordinates, as make it live, all right? We want to convert it into a variable. You need to assign it as a variable. So what I'm going to do is that I'm just going to right click on the X coordinate. I'm going to say store, and I'm going to store that as X. And as you can see, 0.126 is now going to get bold, all right? That means it's become live. It can be tracked. Similarly, on the Y coordinate, I'm just going to right click along the Y coordinate and say store. I'm just going to call it Y, and the Y coordinate now, both X and Y coordinates have become bold. That means they are live. They can be tracked wherever the point A is now going to move along. So on this list now, here I'm going to enter the formula for capturing the data. So I'll go to menu and data capture, and we are going to do this manually, right? And so where it says variable, I want the X, that point whose coordinate I have assigned as X, the X coordinate, that's going to get captured on list 1. So I hit enter. And the same thing if I do it for the Y coordinate here, I'm going to go on menu, data capture manually. And I'm going to say manually that variable that I've assigned on the graphs page as Y, those variables are going to be captured here. Okay? So we've got list 1 and list 2 all prepared and set. So what we're going to do now, watch very carefully. I'm going to take my mouse pointer to that point A and make sure that you grab that point carefully, and this might take some time, this kind of thing, moving the point to the next particular point. I want to move it to next position, and before I release that grip, can you see that became almost like a grip? Before I release the grip, press command if you're on a Mac and control if you're on a PC, command, and before you release command, press full stop. Okay, so command full stop on a Mac, control full stop if you're on a Windows machine. And when you've done that, let's go and take a look at the list and spreadsheet. You can see that position, the X coordinate, the new position of that point A was 0.818 and the Y coordinate was 1.7, and that has been registered here. Can you see that automatically? It's captured. Let's do that for another position now, okay? So I'm going to come here, and this has to be very careful. Okay, so I'm going to bring it to another position and command and full stop, release, and there the second position has been captured. And I'll do that for as many points as I want. The more points you have, the better the curve fitting, all those exercises is going to be. So I'm just going to go, for the sake of this exercise, we're going to go and take some more points. The third point is there. I'm going to repeat it. Maybe I should fast forward this video. One sec, I won't fast forward it. So you can see that again and again. And maybe, you know what, while I'm doing this, I must say this works better on the laptop, on a computer screen. As it is, the image will only come through, you know, you'll be able to insert the image on the computer. That's one reason. The other reason is also this kind of feature, you know, where you are so dependent on the trackpad. It can get a little tricky. It takes some time getting used to that trackpad. So This kind of exercise needs both hands, a bit of finesse using the different keys. So I have, while talking to you, managed to get in a few points. I'm coming here that way, and I'll go directly there and get that original point also, whatever that point was. Okay, I'm just going to go there and command dot. And when I come to this page, can you see all the entire list has been populated? Okay, I've got a set of about, yeah, 10, 12, yeah, 12 points I've got. That's good enough. Now, what we're going to do is that in order to try and find out what kind of curve, as you can see, you have some idea that it probably looks like a quadratic, okay? So we're going to try a quadratic regression and find what that equation is going to be like. So using this data now, we can go and say menu, statistics, stat calculations, and I'm going to try a quadratic regression using those 2 points, okay? So for that, my X list is going to be coming from list 1. My Y list is going to come from list 2. Save regression equation. Well, we're not actually using a regression idea to try and interpolate or extrapolate. We're just trying to find the equation. So that doesn't matter. It can stay on F1. And then the results can be displayed on a column starting from C. Hit enter or OK. That is my quadratic regression that we just found out using those 2 sets of points, X and Y coordinates of the point A moving along that curve of that particular bridge. And this is A, B, C, the coefficients of x square, the coefficient of x and the constant term. You can copy that down. But if you want to see, but we're not actually doing a regression analysis here, so that's not going to matter. This is just about finding the curve. But we've used the idea of regression to get the equation that goes through this sets of points. But now if you want to actually take a look at the curve, what we can do is that since we're on the graph page, this is the cool part. I can bring back my function entry line. And I say, remember we said that we wanted to save the equation to f1x. So I say f1 of x and watch what's going to happen. That's my curve. And it fits just right there. Can you see that? How beautiful is that? How beautiful, how such a perfect match it is. And the more close, the more accurate you are with your points when you are actually doing this exercise, which is why I said it works better if you're using on the laptop, the better fitting the better fit your curve will be. So this is how you can use data capture manually. You can also do it automatically, but this is a very basic example of using data capture, using a picture and manually trying to figure out what kind of curve best fits those sets of points. There are other ways that data capture can be used, other powerful ways, and we shall take a look at that in the videos that will follow. If you found this video helpful, do mention that in the comments below. And if you've already been using data capture in your class, in your projects, do mention that also in the comments. I'd love to hear from you. I'm going to see you all in the next video.